Hello, everyone. Happy Monday. I hope you all had a wonderful, safe weekend while practicing your social distancing. It's very important that if you are not considered an essential employee or place of business, that you're staying home and only going out for groceries or necessities. Arizona is quickly growing in the number of coronavirus cases, so make sure you're heeding those warnings as well. So for today, for chemistry, we're going to finish up. We just have a few more slides for chapter 17 covering the electrolytes, and then I'm actually going to continue on and review the acid and base PowerPoint in this same video since there's not much left of the other. Your daily assignment is strictly around this chapter 17 PowerPoint. So use this PowerPoint to help you with your daily assignment in addition to the lecture review. So continuing on, we kind of left off around the different disorders of acidosis and alkalosis. So acidosis occurs when the extracellular fluid contains excess hydrogen ions, which causes the pH of the blood to drop below the normal range. So your normal range of the pH of your blood is right around 7.4. That's considered the neutral zone. So remember, when we talk about dropping below, we're going into those lower numbers, 0 through 6. That's an acidic environment. That's where acidosis, can take place within the body. Some of you missed that question in your not only your chapter reviews, but also some of the additional questions that I had posted to you guys regarding the acidosis. So I think you were getting confused. The pH scale is really weird. We don't think about it being in that range. From 0 to 6 is acidic, and then 8 to 14 is basic. Our brains kind of want to flip-flop that, but don't do that, okay? So metabolic acidosis occurs when excess acid is produced and bicarbonate is lost. So bicarbonate is what we have to bring our acidic to a more base, right? So think about sodium bicarbonate, things like Tums, baking soda, okay? Those are bicarbonate components that decrease acid levels. Respiratory acidosis results from the slow breathing and retention of carbon dioxide in the blood. Alkalosis occurs where there is a loss of hydrogen ions, producing an increase in bicarbonate, which increases the pH of the blood. So again, we're going in the opposite direction. There's that fine balance of where our blood should be about 7.4 on the pH scale in that neutral zone. If we have too much hydrogen and not enough bicarbonate, then we are in what's considered acidosis. If we have too much bicarbonate and not enough acid, then we go into alkalosis, which is where our blood is in that 8 to 14 range. Metabolic alkalosis occurs when excess acid is excreted by the kidneys or is lost from the stomach, and respiratory alkalosis results from rapid breathing where more carbon dioxide is exhaled and eliminated from the blood. So your acid and base balance, so acidifying and alkalizing agents, for example, ammonium chloride. This is an acidic substance used to treat hypochloremia and metabolic acidosis. It prompts the kidneys to use ammonium instead of sodium in excretion, resulting in the reduced availability of sodium for making sodium bicarbonate. So we can actually give this as an intravenous drug. Sodium bicarbonate, again, we can find that in many different forms. It's a basic substance used as an antacid, a systemic alkalinizer. It's really Sunday I'm recording this, so it's been a long day. Alkalizer for treating metabolic acidosis, and urinary alkalizer when treating hemolytic emergencies and drug overdoses. So when you think about that, drug overdoses we use as well because it's gone into not only the effects of the drug specifically and how that can stop our respiratory systems from working, but also too, it does eventually increase the acidity of our blood. It's available as tablets, oral powder, and IV form. So sodium bicarbonate, which is baking soda, sometimes can be used to correct acid-base imbalances. It can be found in the pharmacy and grocery stores. When combined with moisture and an acidic ingredient in baking, sodium bicarbonate produces bubbles of carbon dioxide, and that's actually what helps baked goods rise. It's a pretty little interesting fact there. So again, some of the things that we find over the counter with that bicarbonate are going to be baking soda, Tums, okay? So what's the difference between acidosis and alkalosis? So again, pH compared to normal range. In acidosis, the pH is below the normal range, in that 0 to 6 range. Alkalosis is when the pH is above the normal range, so from 8 to 14. Ions in excess, so with acidosis, our plasma contains excess hydrogen, and in alkalosis, our plasma contains excess bicarbonate. So again, think about the pH scale when you're remembering answering questions regarding acidosis or alkalosis, that don't let your brain flip-flop those numbers, okay? So 0 to 6 is acidic, acidosis, 8 to 14 is basic, right, bicarbonate, and it's alkalosis. And that covers that. So let's go. I'm going to just jump in here real quick to the acid and bases PowerPoint. It's not very long, just some slides here. I just want to kind of go through it quickly just to give you a video lecture version of this. So in the introduction here, it says, so some foods are sour, but why? So foods like vinegar, lemon juice, and the reason why they're acid is, or sour, is because they're acids. The acid term is derived from a Latin term, acere, which means sour or sharp. So in 17th century, Robert Boyle, who was an Irish writer and an amateur chemist, he was actually the first to label substances as either acid or base. He couldn't identify why he was giving them these characteristics, but he did. So as early as the 17th century, this amateur chemist was actually on the road to discovery of the difference between acid and bases. So acids, their characteristics is they typically are sour taste. They're typically corrosive to metals. They will change litmus paper red. Those of you that have had chemistry, if you haven't been out of high school very long and you were in chemistry, you should have done those chemistry experiments using litmus paper. And then acidic or acids become less acidic when they're actually mixed with a base solution. So your bases are typically slippery to the touch. They will change litmus paper blue, and they become less basic when they're mixed with acids. Arrhenius, so in the late 1800s, he suggested that water can dissolve many compounds, both acid and bases. And he determined that this happens by separating them into their individual ions. So acids, when they are dissolved, will release hydrogen ions into the solution. So for example, hydrochloric acid will break separately into hydrogen and chloride. So before they were together to make hydrochloric acid, hydrogen and chloride form together to make the acid hydrochloric acid. When you introduce water to that, it actually separates them out. So you have separate hydrogen ions and separate chloride ions when the water is introduced. Bases dissolve when hydroxide. So the difference between adding water to acids and adding water to bases. So when you add water, the release of hydrogen takes place in acids. In bases, when you add water, hydroxide is the ions that is released into the solution. So for example, sodium hydroxide breaks into separately, so together sodium hydroxide is together. When you add water and it breaks those hydrogen ions separately, you will then have sodium separate and hydroxide separate. His theory explains that all acids are similar and all bases are similar, okay, and that's actually true. So the reason for that is all acids will release hydrogen into a solution, whereas all bases will release hydroxide into a solution. Acid and bases actually counteract each other, so an acid can make a base weaker and a base can make an acid weaker. This is achieved by the chemical breakdown when the two substances are actually combined together. The neutralization of an acid and a base will almost always produce either water or some sort of salt form. So the pH scale was invented to measure the level of acidity in about 1909. So P stands for potential, and H stands for hydrogen. Again, acids release hydrogen, okay? So the number in the pH scale is an exponent of 10. So this is pretty interesting, and most people don't realize this, that so from 0 to 1, that's an exponent of 10, okay? And then it just increases from there. The scale range for the pH scale is 0 to 14, with your 7 being your neutral zone. So 0, less than 7 are considered acids. Greater than 7, so 8 to 14 are bases, and your 7 are neutral substances such as pure water, and actually our blood should be more of a neutral substance. So a pH of 0 is 10 times more acidic than a pH of 1, and 100 times more acidic than a pH of 2. So again, each one increases by an exponent of 10. So examples, acids. This was pretty interesting. I'm going to hope that you looked at this slide to see kind of where things that we actually consume on a daily basis fall within this pH scale. So 0 would be hydrochloric acid, battery acid. 1 is stomach acid. So that makes sense. If you read your announcement where I talked about it's not recommended to eat sushi if you've taken any sort of antacid medication 2 hours before or 2 hours after eating sushi, and that's because it can decrease the amount of acid in our stomach. So sushi is raw food, raw fish, and there's always a risk or possibility that there's some sort of bacteria or viruses contained within that raw fish that would typically be taken care of if we cooked it properly, but people like to eat sushi, which is raw. And if you consume any sort of antacid or stomach acid reducing medications, your body is not up to par, or your stomach acid is not up to par to kill off any of that potential harmful bacteria. 2 is lemon juice, 3 vinegar, soda is considered 4, which makes sense. I mean, a large population of us in the United States, our pH isn't where it should be with our blood, and that's mainly because of soda consumption. Rainwater is considered a 5, 6 is milk, neutral zone, pure water, or blood. And then our bases, so 8s are egg whites, 9 baking soda, 10 Tums, which is an antacid. We can buy those over the counter. 11 is ammonia, 12 is mineral lime, 13 is Drano, which is interesting, and then 14 would be sodium hydroxide. So very strong acids, so a very low pH from 0 to 4. They freely dissociate in water because there's a lot of hydrogen ions to break apart. So the higher the number on the pH scale, or I should say the lower the number on the pH scale, so 0 to 4, anything within that range has a ton of hydrogen ions in it. So it's easily and freely disassociated in water because there's so much of those hydrogen ions that are able to be broken apart. A weak acid, so the pH is there close to 7, so from 4 to 6, okay? These typically only partially dissociate because there's not as many hydrogen ions to break apart in that range of that 4 to 6. A strong base is a very high pH, so we're going in the opposite direction. So from like 10 to 14. These typically freely dissociate because there's a lot of those hydroxide ions that are able to be broken apart. A weak base, so from 8 to 10, 8 to 9, okay, in that range, they typically only partially dissociate because, again, there's less of the hydroxide ions in those to break apart so easily. Acidosis, okay, we're going to cover this a lot. Acidosis is high levels of acid in the body. This is what allows parasites, yeast, viruses, and rebellious cancer cells to thrive. So cancer actually thrives in an acidic environment. It thrives in it, it loves it. So a lot of the cancer treatments also involve making sure that the patient's pH level within their blood stays in that neutral zone so it doesn't add any fuel to the fire of the cancer cells replicating. Symptoms of acidosis include insomnia, water retention, recessed eyes, migraines, dry stools, causes. So there's many different causes of acidosis. So improper functioning of the kidney and liver. You can have adrenal disorders. Poor diet is probably the number one cause. Stress, anger, control problems, anorexia, too much vitamin C, or too much niacin can increase the level of acidity in your blood. Alkalosis is high levels of bases in the body. So this allows for overexcitability of the nervous system. Symptoms include sore muscles, creaking joints, drowsiness, protruding eyes, night cramps, hard stools, thick skin, and typically causes of alkalosis include high cholesterol, vomiting, endocrine imbalances, diarrhea, and poor diet. So when you have a patient that is on the verge of dehydration, let's say they got a stomach flu or they got food poisoning, or even pregnant women that are having a hard time keeping their morning sickness under check and they're vomiting a lot multiple times per day, they can very quickly go into an alkalosis state because we're expelling everything out of our system. So acid forming foods, one of your questions was to write these down. I wanted you to take a look and kind of see where you were at within your diet and see what you were eating more than others, and seeing how you could kind of increase that balance between the two acid forming and alkaline forming foods that you eat. So alcohol, artichokes, cranberries, sauerkraut, shellfish, tapioca, those are just a few. Beer is also included in those acid forming foods. Alkaline forming foods, avocados. Avocados are just fantastic for you altogether. Fresh fruits and veggies, fresh coconuts, goat's milk, molasses, wine, and yogurt. Neutral foods. So we have neutral foods that we use typically, there's not many, but typically all of the vegetable oils that we use to cook with. Sprouts, all sprouts are neutral, and then sunflower seeds are neutral. Plain sunflower seeds, not the salted ones. Ultimate diet for good health. So the balance is having 70% of alkaline forming foods and 30% of acid producing foods. So that 70-30 range is what we want for optimal health and optimal balance of our acid and bases within our system. So what's happening in your body? So extended pH imbalances are not tolerated. So it can impact your breathing, it can impact your circulation, your digestion, your hormonal production. So basically cells are becoming poisoned by their own toxic waste, and then they die. The pH of our cells and fluids govern our metabolic activities. So in an acidic pH, we can wear out and burn up our electrical responses too quickly. In an alkaline pH, we get sluggish and congested, so auto-intoxication or self-poisoning. So it's kind of two extremes, right? One extreme on each plane there. Continuous acidic pH, so if you have a continuous blood that is in a higher pH or lower pH in an acidic level, you run the risk of having long-term damage. So it can eventually eat into the walls, cell wall membranes of the hearts, the arteries, and the veins. It can weaken the heart. Your arteries will become dilated. Blood is shifted more centrally, which actually adds to the workload of the heart, and eventually can lead to lethal cardiovascular events. Acidosis decreases the oxygen affinity of hemoglobin in our blood. So if cell reproduction is limited by a decrease in oxygen, then there's less energy to power our cells. And eventually they will just break down and die. So this affects both the DNA and the RNA synthesis and the natural cleaning and healing process of our bodies. Again, cells cannot and should not be acidic because cancer typically grows and thrives in these acidic environments. Acidic pH accelerates and increases the possibility of cellular mutations, which is where the cancer comes from. So that covers both the rest of chapter 17 for your electrolytes and the acid and bases PowerPoint. I just wanted to give you a few more tips. Tomorrow, which will be Tuesday, will be the start of both discussion boards for both classes. Make sure you're participating in those every single day. I have also posted your weekly homework assignments. Just a few reminders. I have been having to send emails to some of you about getting your daily assignments turned in. And this week, I've been lenient the last 2 weeks, but it's been 2 weeks now. You guys should know what the expectation is and how to get these done. And so for this week, if it's due the same day. If you turn it in late the next day, it'll be a 10% deduction, and then I am not accepting it after that. You will get a 0, and you will be marked absent for the class. Do not do this week. Do not fail this week. Okay, that will lead to your failure of the course very quickly. Those of you that are supposed to be finishing up this week and headed to extern, you will, as the last I heard, be going on a leave of absence. You should be hearing from Cindy here shortly regarding that. We're not sending any students out onto extern, and the reason for that is you've technically not finished the course. You still have your final exam and the skills checkoffs that we have to do, but we can't do those until we come back to the campus. So if you have questions about that, please email Cindy, please email myself, but you don't want to have to push that date out even further because you didn't participate the way you were supposed to in the last week of class. For those of you that it's almost done, you got 5 days left. The light at the end of the tunnel is there. I promise you, just keep going, keep pushing through, and you guys are going to make it okay. Again, email me if you have any questions, and we'll just keep plugging along.